isosceles triangle is simply a triangle with two congruent sides. So a triangle with two congruent sides. And we mark those sides congruent by giving them the same number of hash marks. And it doesn't matter what the orientation of the isosceles triangle is. If there are two congruent sides, then it is isosceles. We're going to look at how in an isosceles triangle the angles are, or the base angles. So the base angles, in looking at these up here, they're going to be the ones that are opposite the sides that are congruent. So this would be a base angle. This would be a base angle. This would be a base angle. This is a base angle, and this is a base angle. So even though this is not sitting on its base, it is still, those are the base angles. Let's look here. So this is an isosceles triangle. This side is congruent to this side over here. And in order to discover some things about the angles, we're going to actually start by constructing an angle bisector. So remembering how to do that, we are going to put our construction tool here. I rotate my paper because that's easy. We can change the width of our compass between step 1 and step 2, but we're going to keep it the same from both sides. So we're going here, we need an arc, turn it around, need an arc. And then using your straight edge, go through that point, creating this. So because we've constructed an angle bisector, we know that this piece and this piece are congruent. We're going to mark those with one marking. Let's look at what happens when we create a perpendicular bisector as well. So let's take that base, and remember we would be opening our compass more than halfway, and we would be putting the mark, maybe slipping a little here, and we could go the other direction. What I'd like you to note at this point is that this perpendicular bisector that would go through here is going to be the same. So those are 90 degrees. So if this angle and this angle are the same, and this angle and this angle are the same, then we know that this angle and this angle have to be the same. I'm going to go ahead and highlight because this is a theorem. Of course, we're going to use this theorem in proofs, so you're going to want to make sure you know where this is and what it says. So if two sides of a triangle are congruent, if you don't like writing that word, you can use the congruent symbol, then the angles opposite those sides are congruent. So in this picture, we have a 4 and a 4, that makes those congruent. So if AB is congruent to CB, then angle A is congruent to angle C. We're going to go ahead and roll right into the converse of the isosceles triangle theorem. I like to highlight the theorems. So if two angles of a triangle are congruent, then the sides opposite those angles are congruent. So this says if angle A is congruent to angle C, so they're given 41, 41, those are congruent, then AB will be congruent to CB. So the isosceles triangle theorem says if the sides are congruent, then the opposite angles are congruent. And the converse says if the angles are congruent, then the opposite sides are congruent.